Well, hey everybody, it is Thursday. It is a beautiful Thursday, and we are here. I am going to take off my glasses so we can get ready for the show. I am just making sure that we've got everything set up on our streams. As usual, my show often starts off with making sure that everything is working properly.
Is your microphone muted?
My microphone's on. Believe it or not, it's on. So we're not going to have to worry about that today. So today's build is going to be really, really fun. We have a... have you ever noticed that sometimes when you talk, you say more than you naturally do? Like if I'm talking to the camera, sometimes I say a lot. But then I can talk to you and we can have a pretty normal conversation without saying a billion times, right? Like, I don't even hear it. If I talk to you, sometimes I'll say like, totally, whatever. But anyway, we are going to have a really fun build today. It has been an exciting day on the Made New Makerspace property. We sent almost 100 face shields with us, with the folks from the Veterans Administration from their medical center. So that's really cool. So we're making a difference in the lives of people who help our veterans, which is really cool. If you don't know who I am Jim, and this guy right here is Lucas. He is my co-host. This guy right here is Frank, and Frank is tied up at the moment, so he won't be joining us today. But we're going to build something really exciting to add on to Luke's awesome invention from yesterday, and it's something that we'll even use for the rest of the week. Next week, tomorrow is a Free Build Friday. It's going to be great. There's a few things you're going to need, but we'll tell you that right after the break. I am Jim, and you, well, actually, Luke, what are we watching? Why don't you tell them?
Kitbashing!
All right, welcome to Kitbashing. My name is Jim. I am your host for this amazing show, and this is my co-host, Lucas, who is my build apprentice. What is a build apprentice, you say? Well, a build apprentice is someone who is learning from the person who has experience, and I have experience making all sorts of cool things, and Luke right here is the guy who is going to be learning how we do stuff.
I have building experience.
This is true. You have building experience, but every now and then, have you ever noticed that sometimes when you build something, I come back and maybe I'll change it, or I'll tweak it, or I'll do something like that?
I was going to say in Minecraft.
In Minecraft, okay. Well, in Minecraft, you are the master of the universe. I will admit this. I would be your apprentice in Minecraft because, let's face it, I know very little about it. I know there's Endermen and creepers and things like that, but we won't get you started. I don't want to hear about it. Not on this show. I know there might be a lot of Minecraft fans watching. Go to YouTube, Google Supercrafter L, and you'll find him, and he can tell you all about it. But anyway, today we're building something really cool. We are actually building a grappling hook that will grapple on to your door so that you can hang things from a doorway and you can run experiments in a door. And we have a door right over here behind my COVID-19 board, and so we will be running one experiment today, and we'll be getting set up for next week. Here is something super important. For next week, you need to have glue, and I think I said that at the beginning of this week or the end of last week or whatever. We didn't wind up getting to those projects, but Monday, we will be gluing stuff. So Monday, have glue, and it can be Elmer's glue, it can be super glue, it can be wood glue. One of those, any of those is fine. It maybe could be glue sticks. I don't know if those work the best, but I'll experiment tonight and I'll let you know tomorrow. But some sort of glue, you need it for Monday. Keep that in mind. All right, so here is today's project. I'm going to show you on our overhead camera. So we've got some supplies here, and here's what we're going to need to do it. we're going to need yesterday's build. And if you didn't see yesterday's episode, episode 18 is where that is. Now, if you didn't build this and you're watching live at 1 o'clock, you can ignore that build for right now. And after the show, you can go back and watch it and you can put it together. You don't need this for the grappling hook project. That's just for the experiment afterwards. But if you have yesterday's build, then we've got 4 of our L brackets. So those L brackets we've been using for several other projects. I think the last time we used it would have been on Newton's Cradle, maybe? It's been a little while, so you might have to go pull them off of something. But for these L brackets, you're going to need 1 of the 1x5 brackets, and I have given these names based on the holes. They have 1 row of 5 holes. So if you're looking through your kit, you've got that. Rubber bands, you will need... I just put an assortment of rubber bands. You might only need 1, but I grabbed 1 of my big rubber bands and then just some of the other assorted ones. You will need 1 of the long bolts or machine screws from your kit. You will also need 1 of the nuts. And then last but not least, you're going to need the carabiner clip. So if you've got all of those things, you have everything you need for today's project. It's going to be a super easy build, but the point of today's build isn't necessarily to build something amazing and extravagant. It's to build something that adds to yesterday's creation and gives us a way to test in a repeatable manner. One of the biggest things about scientific principle is that when you conduct tests, they need to be tests that can be easily replicated. What does that mean, Luke, replicating a test? Replicate. If I said I need to be able to replicate a test, what does that mean?
Whatever you think it means.
No, not quite whatever you think it means.
I know. I'm just saying whatever you say it means is the answer.
Yes, that is true. Whatever I say it means is the answer, but it is also what it really means. Do you know what it really means?
No idea.
Okay. So to be able to replicate a test means that you need to be able to do the exact same test over and over and over again. And so, for an example, I'm going to set up my desk cam here so that we can see the desk space. All right, we can see the desk in front of us. Now, what I'm going to do is I'm going to take my friend Frank. All right, Frank, he's all tied up at the moment, but he can still help us with this. Now, I know that Frank is about the height of my hand, and I'm going to drop him. And let's say, and for the purposes today, I don't have a stopwatch ready to go, but let's say that we were going to drop Frank from this height. Okay, and now to replicate the test means to be able to do it again and again and again, and then be able to log those results so that you can test whatever result you're going for. Luke, have you identified a problem with this method of dropping Frank and measuring it yet?
We don't know how long it is.
How long what is?
How long it takes for it to hit the ground.
Okay, but that's the part we're measuring, so we don't need to know. But what... Now, take a look at what I'm doing right now. 1 drop here, 1 drop here, 1 drop here, 1 drop here. Did you notice...
He stood up.
Hey, he stood up. I should get some points for that. But did you notice something that changed every time?
Sometimes he would fall down, and one time he stood up.
So the way he landed changed, but what about the way I was conducting the experiment? So there's 2 things you need to consider anytime you're doing an experiment. You need to consider the results of your experiment, but you also need to consider how you conduct your experiment. So like I got Frank here. I unwrapped him. Frank's buff. Look at that. I didn't know we had like Legos that worked out. Anyway, here's the problem. Let's go back to my desk cam. Now, I want to show you. So let's call this experiment 1. I've got Frank up here, and I drop him, and I measure that time. Okay, so I was up here, and Frank went down here, and let's say that took 0.28 seconds. Now, let's say that I drop him the second time. Look where I'm dropping him from now. See how that's much lower? Up the last time it was up here where my finger is. This time he's only about half as high. And so I drop him again, and this time when we measure our time, we get about 0.15 seconds. That's not a good way to test a hypothesis in science. Do you know why, Luke? Why would it be bad if one way, if I'm just kind of guessing how high he is and I just drop him from about that high every time?
It's because you don't know the exact height. You have to know an exact height or else your results might change. Like, let's say...
right. No, you're exactly right. So you've got too many variables. In a good scientific piece of research, what you want to do is you want to eliminate all the variables except the one you're testing. So if I'm testing the amount of time it takes for Frank to fall, I need to first find out how far he's falling. That was a lot of F's in one sentence.
That's exactly what I was thinking.
For Frank to fall, you've got to figure out how far Frank is falling first. Frankly, let's go over here. So, Luke, we've got Frank, all right? So what could we do to help figure out how far we're dropping Frank from?
We could get our ruler piece and see how... and drop him from the same height every time.
Right, so we could get a ruler, but honestly, the other thing we can do, as long as we have some frame of reference, so like I've got this 1x5 from today's build, as long as I have some frame of reference that doesn't change, we can eliminate that variable. So Luke, why don't you put Frank so his feet are right at the edge there?
Right here?
So, right at the edge, and then drop him, okay? Now put him right at the edge and drop him again. My result is going to be about the same every time. Now, depending on how the dropper drops him, that's another variable. Now, sometimes in a situation like that...
Here, you did another one.
What's that?
Depending on how the dropper drops him.
So, depending on how the dropper drops the droppee, Frank might find himself falling faster than he could fall in a normal situation. I've unfurled quite a bit of F's in that sentence. Anyway, so here's the other thing, is some variables you can't perfectly control. So like, for example, what we just covered was that Luke put Frank on top of our tower measure, but depending on how he let go, he might fall this way or he might fall this way. And so that's another variable, is that human error factor. And you have to take that into account when you are doing measurements and when you're doing scientific testing. That's a variable you can't always get rid of. Now, we can build machines that do a lot of cool stuff for us, but those machines, the thing with those machines is that they are also built by humans. They might reduce a lot of the error, but they're not going to reduce all of the error. And so you have to make sure that when you test, you account for those possibilities. And scientists will do that. And you'll see in scientific research that they will actually put in there the margins of error. Luke, that's another question I have for you. Maybe you've heard that phrase, there's a margin of error of whatever. What do you think a margin of error means? Just give me a guess and I'll tell you if you're right.
A lot of mistakes.
So a lot of mistakes. Well, a margin of error simply means that this is how far off we think we could be. And it's sometimes it's kind of a guess. Sometimes they have more information. But like, if I'm testing something and I know that I got all of my variables eliminated and I'm only testing this one variable and things stay the same all the time, I've got a very small margin of error. I'm using these as pointers, a small margin of error. But let's say, for example, that I don't know. Maybe I have to have humans involved in this and they behave weirdly sometimes. Maybe I have something that might, vary in a computer program, for example. Maybe the program is mostly random, but every now and then it seems like it pulls the number 3 more often than another number. Okay, so those things widen your margin of error. And that tells you how much you can trust it. If you see a scientific research study that has this huge, gigantic margin of error, you can probably trust that scientific study less than one that's got a really itty-bitty margin of error. All right, so we've talked a lot about the process of doing scientific research and how that works. Today's episode is not all about that, but next week we're going to do some fun research stuff. Fun and research can be in the same sentence. I just said so. And to get there, we need to build a grappling hook. Now, this grappling hook We're going to use it for some science stuff and learning things. But this is just fun because we're going to build something that can grab on to the top of your door frame and you can pull stuff up from it. You can use this to make your Lego guys go on flights. You can use this to launch crafts from. You can do all sorts of stuff. So we're going to create it, and how you use it is totally up to you. Here's the first step. So first step, I've got my 4 L brackets. Luke, you're my build apprentice, so I'm going to let you do this. All right, so I've got my 4 L brackets. Here's what I want you to do, Luke. I want you to take those 4, and I want you to take 2 face and have 2 face left and 2 face right. Okay, so you've got 2 that face left and 2 that face right.
Like Newton's cradle.
Yep, and now what I want you to do with those is I want you to take those 4, so you've got your 2 that face left and your 2 that face right, and I want you to sandwich them together like this. So there's left, right, all right? So do that. Left, right, left, right.
Like this?
So, yep, left, right. So now you can, here's the thing, is if you put it all on the ground, it will make a T. Or if you put it all on the desk, it'll make a T shape. So, oh, there we go. All right.
Now, I need to punch all these holes out.
You don't need to punch them out right now. I left them in there. So if you've got the maker kit at home, you probably have a billion of these little guys, and it's okay. You can punch them out. Here's a secret, is that if you punch these out, you should totally save these because they might be useful later. All right, so going back to our desktop cam, you've got those, so let me see what you've put together here so far. So now, if you have continued with us on the build, you're going to have a T-shape or Thor's hammer or whatever you want to call this. I don't know, Thor's hammer looked a lot cooler than this. No. We said no Minecraft. Anyway. I'm just teasing, Luke. Going back to our overhead cam, you have the T. Now, here's the next step. And what we're going to do is I'm going to take my T, and I'm going to take the top 2 pieces. So there's 2 on top, 2 on bottom. I'm going to move those aside for right now. And the next piece is going to be to take the 1x5 and place it in the middle like so. So that the first hole... And actually, I could even place it here so it's a little more obvious. But what we want to do is we want to make sure that our first hole, I guess I didn't say that earlier in the video, you do need to have this very first hole on the long side. You need to have that punched out on all of them. But if you've already punched those out, as I have, then you need to place your 1x5 bracket so that this first hole has the first hole of the bracket lined up with it. And then we're going to take this... and we're going to stack it back on top. And if we line it up really good, now we should have a place... I'm going to look. We do. We should have a place where all the holes line up. Very exciting news. Lucas. So now, here's the next step. And I'm going to have you do this. Wait. I'm going to have you do this so that we can show the viewers at home how easy it is. What I want you to do is I want you to, without moving this a whole bunch, I want you to put the bolt through one side and then take the nut and tighten it on just a little bit. It doesn't need to be super tight. We just want it to hold.
Doesn't matter which side I put it
Doesn't matter which side at all. Doesn't. That's how you know I'm a Nebraskan. I speak fairly clearly, but sometimes I'll use words like doesn't. That doesn't work. All right, so Luke's got that through.
Now, would this be about the right tightness?
Is it about the right tightness? It looks about the right tightness to me. Let me see. Mm-hmm. All right, so Luke was asking if this is the right tightness. So you'll see that, like, if I hold it by this and I let them swing, they kind of swing back and forth, but it's stiff enough that things aren't moving too much. I think Luke got it just about perfect. I might tighten it 1/2, little tighten more, but this is just something to watch now. These are not lock washers. Now, if you have ever used nuts and bolts before, lock nuts rather, a lock nut is a nut that looks a little bit like a regular nut, like what we've used, except sometimes it's got a little slight curve on one end to kind of give you an idea of, oh, hey, this isn't like regular ones. And the reason it has that is because it on the inside there's a piece of nylon that grips onto the threads of the screw really good, so that it once you tighten it on, it doesn't come off. This doesn't have that little piece of nylon, so that means that over time this can get looser and looser and looser and looser and looser and looser. So if you're not watching, sometime this might come all the way off, and then you would really be in trouble. Now, we don't want to do that today, so I'm going to tighten this back to where Luke had it. All right, so that looks really good. So now you should have Thor's hammer with a little tail sticking out. That is exactly what you want. The next step, Luke, I'm going to put this back on the desk. I'm going to let you do this part, is we have to kind of decide. Now, I've got several rubber bands in front of me, because what we need to do next is we actually need to make this into the claw. And I'm going to show you the end piece, but we're not ready for this step yet, is to push the T parts of the hammer out. And then this is going to turn into our claw. Like, this is what grabs. If you remember, I want to say it was the very first episode. We made something similar to this grappling hook for another project. But we're going to do that.
It was the thing where you can... It was like kind of like scissors.
Yeah, I think that was what it was.
Thing.
But one thing you'll notice is that on the bottom of this, on each one of these, there's a little piece here. And that's designed. We had a real engineer who works for the Union Pacific. Thanks, Eric. Designed this. And he designed this with this little grippy deal here, so that if we put rubber bands around the bottom, it will actually hold when you turn this into a claw. This was really well engineered. So what I'm going to have you do, Lucas, is I'm going to have you take the rubber band, and we're going to wrap it around, and you're going to have to wrap it a few times around, so that in the end it's wrapped around just this end piece.
But is this supposed to be in here?
Yeah, I put it on there just now.
But it was like stuck inside.
Oh, well, if it's stuck inside, then we can move it a little. But anyway, you're going to wrap it around so that it's wrapped around the whole bundle, just like that. Okay, but one thing first, I want to ask your opinion, because I have a couple different options here. I have our standard long rubber band. I have one of these little rubber bands that would probably wrap around that whole thing one single time and be done. And then I had some of my assorted rubber bands, like this green rubber band, which is kind of, halfway between these three. So I've got little, medium, and regular sized. What, in your opinion, Luke, which one do you think would be the best rubber band? Should we use a small rubber band that we only have to wrap around once? Should we use a medium rubber band that maybe it will go, 2 or 3 times? Or should we use the big rubber band, which we'll have to do a few more times than that? What is your thought?
I think the little one.
Okay.
Because then we could go around this whole thing once.
Uh-huh.
And we could just... Well, it is one of the easiest choices, but sometimes the easiest choice isn't always the best choice.
That's a very good point. But sometimes the easiest is not the best.
The large rubber band, we would... it wouldn't be very tight.
Right.
So,
the large rubber band, if we just did it once, wouldn't be tight. But maybe if we wrapped it around a few times, it might.
I think I'll take the medium.
Okay, so Luke wants to try the medium rubber band. Why don't you try that, wrap it around a couple times, and let's see.
Let's see what it can do. So you want it like this?
Yep, and then you're going to twist it and go up and around one more time.
2 or 3 times. I think we could go one more.
If you can go one more, do it one more.
Wait, am I only supposed to take one of these?
You can do one, yeah, just one is fine.
Whoa. Come on.
Good work. All right. It doesn't need to go quite that far up the base, just the very end. See where those little parts are? Here, I'll take that as it is because I want to show them on the camera.
This keeps getting loose.
Yep. Here, pass
we
it
need
this
one
way.
of those lock nuts.
That's what we were just talking about. Were you here when we talked about that a couple minutes ago?
Yeah.
I don't think he was here. He wasn't paying attention. Anyway.
I know. You said, you talked about what a lock nut is, and I just said we need one.
Yes, we do need one. All right, so Luke, when he wrapped his rubber band around, it was almost to where the nut and bolt are. And you don't need to go quite that far down. You just need to go down where this little tab is right here on the end. So the little tab on the end is all that you need to do. Now, we're going to test this because Luke chose the green rubber band. And I think that was fine. I'm going to pull this open and feel how that feels. Okay. All right. So, Luke, I want you to try the same thing. I want you to feel how that feels. Just a general feeling.
Uh-oh.
Uh-oh. I love when uh-oh happens. That usually means something bad is going on.
This.
Just one of those fell out? Okay, that's not a big deal. I'm going to see while you're testing that. I thought I had... Oh, I don't have it here in my desk drawer. I usually have a fish scale that I could use to test the pressure on this. But we'll talk about that next week. All right. So now, Luke, here's the next step of our experiment. We've done a lot of experimenting today. Here. The next step is I'm going to take off this green rubber band, and now I'm going to put on our single itty-bitty baby rubber band. All right? Now, in science, remember what I said yesterday, how you make a hypothesis, then you test your hypothesis to see if it's right. We've eliminated most of the variables because this will behave the same way every time. What do you think, Lucas? And maybe I can even give this a second twist. Maybe. I think I can do it twice. That's tight, but it's there. What is your hypothesis now? What do you think this pressure will feel like?
I think it'll be tighter.
Do you think this will be harder to open or just the same easiness or easier?
I think it'll be... I think it'll be harder.
So there will be more pressure on the jaws? Okay. So I'm going to pass this over to you, and I'm going to have you test it out. Now, remember what it felt like last time.
Actually, this is a bit easier.
It's a bit easier. Okay.
But it's not as... I don't feel as much.
So pass that back. So
I remember last time it was like, boom. But now...
All right, let me see that for 1 second. I'm going to show you something. So now we tried rubber band number 1. We tried the medium rubber band, and Luke felt the pressure of that. Then we put the little red rubber band, which is a lot tighter on there. And Luke, his hypothesis was that this red rubber band was going to have more pressure on it. There would be more tension on the actual jaws. So, Luke, was there more or was there less pressure on the jaws?
There was actually less pressure.
Yeah, and that was interesting. That's an interesting result. That means that there's something happening here. Now, I'm going to do one final experiment. I'm going to take our big rubber band, and I am going to put the big rubber band on the end. So, Luke, while I'm doing this, knowing what you know now with our previous 2 experiments, what is your thought on experiment number 3? What do you think is going to happen? And hang on 1 second. Viewers at home, if you're watching, what do you think is going to happen? If you're watching live, you can comment live. Those of you, I see a few people. If you are watching this recorded later, you can post a comment now in the comments, and then let's see what Luke's hypothesis. Luke, what do you think is going to happen now that I took my one giant rubber band and I wrapped it around several times?
I feel like it might be...
Do you think there's going to be more pressure on this or less pressure on this?
Well, how many times did you put that around?
Oh, I don't know, 5 or 6-ish.
Okay.
I can count if we want.
Yeah.
All right, so let's do the math the proper way, and let's see how many times I wrapped our big rubber band. And actually, I didn't. Yeah, they're the same. Okay, so I took our big rubber band and we wrapped it around 1, 2, 3, 4, 5. Oh, I might get 6. I got 6. We wrapped it around 6 times, Luke. So I wrapped it around 6 times. Versus this one we did like 3. This one we were able to do 2.
Hold on. I need these 2 rubber bands. I've got to test something.
Okay. What are you testing?
So I know we put this one around 3 times, and we put this one around 6 times. So if this one is exactly half the size as this one, then they should be about the same. So, the green one is a bit bigger than half the size. So, my hypothesis is that, hold on, I've got to think about this.
Will there be more or less pressure on our jaws?
I think there will be more pressure.
More pressure. So he thinks there's going to be more. So Luke, here you go. I'm going to hand it over to you. I want you to test it. Tell me how it feels. You're being dramatic. Don't be dramatic. Just be an honest scientist. Doesn't add drama.
Okay, this is actually kind of hard.
It is hard, isn't it? All right.
I'm literally trying as hard as I can.
Okay, let me see it, and we're gonna talk about this for a second. So today, we've tested 3 different rubber bands on here. So this is, again, we're talking about testing variables in the scientific method. And Luke tried the first rubber band, was the medium one, and the medium rubber band, it was okay pressure. Then he tried the skinny rubber band, this little bitty guy, and there was hardly any pressure on the jaws at all. And then finally, we put the big rubber band on there, and we had to wrap it around 6 times just so it would have the same tightness, and that has a ton of pressure. Yeah, that's pretty good. I mean, I'm happy with that. So, why do you think that is, Luke? Let's talk about this for a second.
Well, I was thinking about it, and I was thinking it would be if I knew that if you we put this medium one around 3 times. So if we put that big one around, and then we did the little one, and we put it around 2 times, and it wasn't as much pressure. But then when I put this on, when I put the big one on, I knew that with that big one, since it was doing 6, if it was twice the size as this one exactly, then it would probably be the same as this. But if it was not quite twice the size, it would probably have more pressure because we put it around more times, and it's kind of confusing.
So,
I don't know how
no, that's a good hypothesis. What you're saying is you wrapped it around more times, so that's more pressure. And you're kind of on the right path. Pass me that green one again for a second.
Oh.
Thank you very much.
So,
here's what's happening here. And this is what Luke's doing is he's working out the science of this as we go. So, rubber band 1, in order, this little guy had the least amount of pressure on our jaws. This guy had a medium amount of pressure, and this guy had the most. Now, when I only have them 1 time in my hand, and I'm just doing this once, okay, that actually, that one doesn't feel as tight as this guy, and that definitely doesn't feel as tight as this guy. But remember what we've talked about in the past episodes where we've talked about potential energy. Something elastic like a rubber band has a lot of potential energy, and that potential energy is stored in the elasticity of the rubber. So when I stretch it out, I've created tension now, and that tension wants to pull this back. And so this energy is expended to bring this back. And actually, it's really cool because if you were to sit here and if I was to pull this back and forth all day, what you would see was that this rubber band would start to heat up because that's actually transforming some of that energy into heat as we do that.
I think we're
So,
gonna need some heat.
here's
What's happening?
Yeah, I know.
outside.
We got snow outside the windows here. So here's what's happening. With this one rubber band wrapped around twice, see how small this guy is? He's a little bitty guy. Look how big this is. This thing contains way more potential energy than this guy. This guy's got a little bit of potential energy in it. Little tiny guy. This guy's got a lot more. Now we got this guy, but then you compare this guy to this guy, and all of a sudden it's like, I got some energy. I got a lot of energy. I'm making weird voices. I do that sometimes. You can ask the kids. But this has, and if you look at the thickness, you can see the difference there too. This is not as thick as this. And so that means there's more rubber here and more potential energy. And so if I'm stretching it just one time, it might not feel like it's got that much energy. But if you wrap it again and again and again, so that it's taking up the same amount of space as if I wrapped this one, 2 or 3 times, I can move these fingers apart. I am trying. I cannot move these fingers
Can I
apart.
try?
I swear.
Can I try?
No, because I don't want your fingers to explode. Now, there are several YouTube videos out there of YouTubers. One of Luke's favorites just recently did an experiment where he wrapped a bunch of rubber bands around a watermelon and made it explode. That is the same release of that energy. So those are some cool experiments that you can do at home. Now, today, we're getting towards the end of our time for today's show. I was going to put this on our door frame, and we were going to walk through the experiment, but we've got time to test those hypotheses on Monday. And so what I think we're going to wind up doing is Monday, we're going to test Luke's invention on this, and then we are also going to start for Tuesday's project. Tuesday, we're going to start looking at another concept. And if you think about it, all of these projects we've been doing, they all kind of tie together because we talked about the lever. Guess what we've created? This is a fulcrum. We have a lever. We've talked about potential energy, and we've talked about using the energy of a rubber band to do work. We've done that in several episodes. And so on Monday's episode, we're going to test another hypothesis with Luke's invention versus a modified version that I made, and we're going to see how that works out. On Tuesday, we're going to start working on pulleys, and we're going to start talking about another simple machine that does work for us and how we can ease the load. So that's going to be really cool. We'll also use this carabiner that we didn't use today on Monday. And actually, if you want to use it today, just so it's there and ready to go, clippy on the end. So tomorrow is Free Build Friday, and I've got something really cool planned for Free Build Friday, and I hope you tune in for that. Otherwise, we will see you tomorrow or Monday on Kitbashing. And I am Jim. I am your host. I hope that you enjoyed this. If you did this build and you want to share it with me, please send it to me. Kitbashing@madenewOmaha.com is our email. And maybe you could even hang something from this and show me. I'd love to see what you're hanging up from your doorway. And if you haven't guessed yet, these little notches here, you open this up, you put it over your door's trim, and it will hold these notches. These will sit right on top of the trim of your door, and that will hold it open.
And they bring bounce.
It's super easy. So I would highly encourage you to experiment with this. Send me pictures, kitbashing@madenewOmaha.com. You can also check our website, which is madenewOmaha.com/kitbashing, and that has all sorts of cool information about this program, several previous episodes, all of our previous episodes, as well as some guides that will help you through if you wanted to make your own kit. If you didn't have these pieces today, if you don't have one of our kits, and let's say you don't have access to a laser cutter to make your own, guess what? You can still make your own. The instructions are there. You can print it out, lay it out on a piece of cardboard, and you can make some cardboard versions. They might not be as strong, but that's better than nothing. Lastly, if you want regular updates about our show, see that thing we started at the very beginning of the show talking about? Go to facebook.com/MadeNewOmaha, and we will give you regular updates there. You can follow us there. If you're on our YouTube channel, be sure to like and subscribe because that helps us in the long run. So until then, as I said a moment ago, I am Jim. This is Lucas, my host, and this is Frank, who is tied up at a distance now. And you have been watching Kitbashing. Thanks for tuning in. We will see you tomorrow for Free Build Friday.